Okay, we start this video out looking at a breadboard, and that's because this is an electronic one. So I'm sure at this point you can make a decision whether this is up your alley or not. A little while ago I got a Flipper Zero. Now I have a project involving infrared transmission, and I'd like to transmit infrared a little bit longer, so I have some infrared LEDs. I'm going to find myself a transistor, some 160 ohm resistors and some pin headers. I'm going to try and make the equivalent of an IR blaster. I will probably also need a couple of transistors. I'll see what I've got kicking around. But let's get cracking. Okay, we're going to get the basics started here. We're going to use a visible LED. We're going to check that our resistor is about right. We wanted about 30 milliamps across the LED, which at 5 volts is about 160 ohms. So we've got that worked out. And we can switch this down to 3 volts. It works pretty much the same. This is a 12 volt interface here that has a little regulator, drops it down to 3 volts on this rail here. So we've got our polarity worked out on our LED, our basic circuit's okay. Let's find ourselves a transistor. Alright, I've got some transistors here that were left over from Geiger counter build, and I wonder what these are. Well, that didn't work. Let's try not to mess them up. Well, I guess they're out now, so let's go look up what these are. Let's see here, I've got my little illuminated magnifying glass here. Flip one up. When they stop shaking, these are really hard to read. What do we got here? These are J3303s. Alright, so these are an N-channel JFET, and they're good for the frequency, but their max current drain is about 30 milliamps. So I'm going to be driving them a little hard with this LED. Probably right at their spec, but apparently they're good for up to about 38 kilohertz. So it turns out these might do the job. Alright, so we've got a test circuit going here that is running, and this is my little indicator LED to tell me if I have 5 volts on the power rail. We can go up here to trigger a remote control code. On this is a visible white LED. Everything is correct, and I have been talking to ChatGPT just to make sure that I'm not completely insane. But it would appear that we have the correct pins. So the collector, pin 3, is to the anode of the LED. We have emitter, which is to ground, and we have the base off to the Flipper Zero here via two 390 ohm resistors, because that's all I could find, as close as I could get to 1K. The 160 is feeding that. So if we do test this, we want to test, yes, we can pull 60 milliamps or thereabouts through those LEDs. That does work. Something is not working with that transistor. Maybe I blew it up. I'll flip it around for a new one. Alright, new transistor in. We've got no go. We're still actually outputting, can we see the light there? Yep, we're still flicking things there. Alright, got more drawing board to do. Okay, so change of plan. I found I have a crap ton of 2N3904s. They might do the job too, so let's swap them out. Alright, after a bunch of mucking around, we have a result. So, I was feeding the LED off the negative rail, not the positive rail. Anyway, I found a BC337. I normally use a BC548, so my brain's a little backwards. Not used to working with NPN, the 548's a PNP. Just different polarity. I had operated on a bunch of standard things. ChatGPT, good example of how it's not always accurate. It did also give me a tip on the base current, which we needed about 0.7 volts. So I found two 9.1K resistors, giving me a total of about 4.5 or thereabouts, which gives me about 0.7 volts on the base. Perfect transmission, or perfect operating voltage, and that works really nicely. So now we're going to swap that out with an infrared one and see what happens. Okay, infrared LED swapped, and this camera should be sensitive to infrared. Can we see it flashing? Maybe. Very, very faintly. Let's zoom in a little bit more. Can we see it? We can see infrared flashing there. Okay, I wonder if this will work. It may be that these are just a little bit outside the filter range of this camera. It's a different camera than what I normally use, so let's see it on the TV. See what works. It does, it works and turns it on. Awesome. Okay, so my apprentice is just getting set up for bed. We have amplified this circuit and the focus is not great. Can we see all of these LEDs working? I think it's 1, 2, 3, 4 of them. I think 5. So we do have 5 working. Alright, so that works. I will translate that over to a prototype board soon. But I am going to see if I can find some brighter infrared LEDs. Now, pro tip before you do something stupid like I am here, turn the power off first. Because you can very easily short a pin when you do this. Okay, so the board is starting to take shape here. I'm just stopping for a moment to check my wiring here and make sure that I still had the correct polarity on things. And I'm stuck for a loose LED. Hang on. I have a few loose LEDs in here because I couldn't remember the polarity that I had. I think the long leg goes there, and then off this we should be feeding off ground. So the long leg is our positive in this case. Is that the correct? So long leg through the resistor off positive, short legs to ground. Okay. Where that's relevant here is I need to bend out all my short legs. Make sure I have everything all in the right order here. That is a short leg. Sometimes it can be hard to manipulate them. These are all the short legs here. Push them out a little bit and they're going to create a negative bus bar. Alright, we're making progress. We're just having to point all the grounds. We're hiding some resistors under here which come out. Got about 3 more resistors to put in and we'll be almost ready to go. Now, one thing to note here, I probably didn't strictly need to run 1 resistor for every LED. It just makes the maths easy. If I actually had access to more parts, I could probably go and get the correct resistor to balance the current across all 5 LEDs. I just cannot be bothered doing the maths or going out of the house. This is a junk build. That's why I'm going through a bunch of different transistors, trying to find one in my box of parts. If this works, I'll build a better model later on. Alright, here we have the very prototypey prototype, with resistors all facing all different ways. But, and of course, all the other stuff going on the top here. Sometimes that's what happens with prototypes. I don't think I've got any shorts. It should be right, but we'll see how this works. Right, well, if I'm going to make a mistake, I might as well do this on camera. What's the button to power this up? I know what I'm doing. Alright. Fire things up. Go infrared. Now, it's definitely that way. We can't get this in backwards because of the way I made it. Let's go infrared. Let's go GPIO settings, power. Sometimes we've got to turn the power off and back on again. And then we go saved remotes. Go to my Kogan TV. Okay, let's turn it round, point at the camera. Do we see these LEDs flickering? I don't. I'm going to see if it works. Okay, so it's not working, at least not as best I can tell. Let's check if we have 5 volt and ground on the top here first. So we have 5 volts. That's good. Okay, let's double check my circuit and come back. Okay, so it turns out I had my transistor backwards. Easy thing to do. Can we see flashing IR lights in here? It did successfully turn the TV off. Alright, so I recently upgraded from the S21 here to the S23 that I'm using there. About the day before the S24 came out, so a little bit jilted about that. But I'm going to try this and see if the camera on this is any more sensitive to that range of infrared. One of the reasons I upgraded is the camera lens got water in it, but it might work alright. Let's change here. Let's go to, yes, we're on an infrared setting there. Let's try this. Can we see anything coming out of these? Alright, so I've turned all the monitors off, and I think we can get a bit of a flicker here. Laser rangefinder doesn't like me right now, but I can't. Okay, laser rangefinder stop. So I count 1, 2, 3, 4 working there, and 5. So I think they're all working. I can just faintly see them. Yeah. Okay, that's good. So now it's time to point them all off in different directions. Now, one of the key design purposes for this was to create a sort of a broad spectrum, slightly better field of view infrared transmitter. So this way I can sort of sit in range of a bunch of different things without having to point it directly at it. The infrared LEDs in here, which we can probably activate if we go back out and change our GPIO settings. If we turn 5 volts off, go back to the flipper here, and we go to a saved remote, again the same one I've been using, and I went one too far. This one here. You can see here this one's back much more in the spectrum that this can see. So they're probably 940 nanometer instead of 800 or thereabouts. I think there's 850 nanometer is pretty much what they come in. But these are fairly directional. You can see if I turn away just a little bit, you can't quite see it. So it can be a little inconspicuous pointing that in that rough direction towards a TV. This is nice in that I can sit here and I can do something like, we can go to the universal remote function, go TVs, let it load our settings, and then sit here and run the power thing and just let it scan through and get anything that's roughly in its range. It's a little bit easier if I've got to sit here and scan through to find something on a TV. The other thing too is my apprentice has issues with seizures occasionally. She's photosensitive from time to time, particularly when she's very tired. The plaza that I go to has introduced a whole bunch of low refresh rate LCD screens for advertising, and they are absolute hell. They bug me as well. So if I can leave this sitting here and turn off all the advertising screens for a couple of minutes, there's less of a chance she'll have a seizure. And I have a bit of an ethical objection to having things forced in my face, particularly advertising in a situation where I can't avoid them. And they are definitely putting them in places where you can't avoid them, like the toilets. So in some cases I'd like a small ad-free zone. This kind of helps with that. But we'll let it run through for a little bit, and yeah, that should work pretty well. Of course, with these being able to be bent, I can adjust that. At some point I might take notes from the IR Blaster project. You can buy those. I think they sell them on Etsy. There's a whole bunch of different ones that incorporate very high intensity LEDs. I took one look at the board and went, I see what's going on there. I can build my own. The thing I'm having trouble with is finding the high intensity LEDs. But now I've got all this worked out, I can probably put a bigger transistor and I can probably put bigger LEDs on. But for an experiment as to can I make my own add-on board, the answer is yes, we can do that. So yeah, we'll make ourselves a thumbnail here and go, hey, I can plug stuff into a Flipper Zero. Anyway, we'll see you later, and hope it was an interesting one, and we'll be back with more in the future.